In our last video, we had an introduction about determinants and we have seen how to find the determinants for a 2 by 2 square matrix. Now today, in this video, we are going to discuss about finding the determinant of a 3 by 3 square matrix. So how to find a determinant for a square matrix? And as we discussed that determinant is possible only for a square matrix. It is not at all possible for a rectangular matrix. We had a discussion. Now let us see that how to find determinant for a square matrix which is order 3. For example, here I have a matrix A, A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is about a square matrix with 3 rows and 3 columns. And whenever we have 3 rows and 3 columns, obviously we have 3 3s are 9 elements. So we have, this is, we can call it as row 1, row 2 and row 3. We can call it as column 1, column 2 and column 3. The determinant of a 3 by 3 square matrix, we need to go for expansion way. How to expand it, in what way we are going to expand it. Now for this 3 by 3 square matrix, we can find the determinant in 6 ways. How? We have 3 rows and we have 3 columns. Using any row, we can find the determinant of a matrix A. Using any column also, we are able to find the determinant of matrix A. For example, when we use row 1, we can find one way. Row 2, row 3, column 1, column 2, column 3. So using row 1 or using row 2 or using row 3, using any row, we can find the determinant. Or using any column also, we can find the determinant of this particular matrix A. How? First, we need to choose a row or a column. With that row, we need to expand it. How to expand it means, suppose when we have chosen row 1, now I am expanding the determinant of A with the help of row 1. Expanding in the sense, converting the 3 by 3 square matrix into 2 by 2 form. In our previous class, yes, we had a discussion about how to find determinant for a 2 by 2 matrix very easily. So that B is nothing but the cross of AB minus BC. So when we have a 2 by 2 square matrix, it is very easy to find the determinant. So that the 3 by 3 square matrix we are able to convert into a 2 by 2 form, then it is very easy for us to simplify. Now let us see how to convert and how to expand the 3 by 3 square matrix into the form of 2 by 2 square matrix. Now, for example, now I am choosing row 1. I am choosing row 1. So expanding with row 1. Now I am going to expand with the support of row 1. Now let us see how to expand. Det A is equal to det, the given matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Now how to expand it, sir? That is our question. Just very easy. Now as I told you, we are expanding with the support of row 1. In row 1, what is the first element? We have A11. When we are choosing A11, as I told you, converting the 3 by 3 square matrix into 2 by 2 square matrix. So how to convert it, sir? Good. Now just choosing the first element A11 1, 1. Next, I want 2 by 2 square matrix. Leaving this entire entire column and leaving this entire row, you are able to find 4 elements here, which is in the form of a square matrix. So, here we are choosing A11 is the element. So, whenever we are choosing the element A11, we have to leave the respective column and the respective row elements. Avoiding the row and column elements, when we observe, we are able to find 4 elements here, which is just like a square matrix. A22, A23, A32 and A33. Det A22, A23, A32 and A3. I got a 2 by 2 square matrix. Next, here I have the second element. So, I told you we are expanding with row 1. So, in row 1 first element expansion is over. Now, we are choosing the second element. What is the second element? A12 plus A12. Now, when we are choosing A12, when we are choosing the element A12, now the corresponding elements we have to eliminate, means that, so the corresponding column elements and the corresponding row elements. Here the corresponding A12 means the entire second column elements we are eliminating, the entire first row elements are also we are eliminating. Now by eliminating the corresponding row and corresponding column elements, whatever the elements are left over, here I have A21, A23, A31 and A33. With this again I am getting a 2 by 2 square matrix.
A31.
So A21, A23, A31 and A33. Next, coming to the last element of the first row, that is nothing but A13 again plus A13. Again we have a 2 by 2 square matrix. What is the 2 by 2 square matrix? Now, so as we know that the corresponding, this is A13 means first row of third column. So the entire first row elements we are eliminating and the column 3 elements are also we are eliminating. Now by eliminating first row and third column elements, so we have 4 elements. What are they? A21, A22, A31 and A32. So with these 4 again I have a square matrix, that is A21, A22, A31, A3. Now, next, here I have kept a gap. So, what is the gap indicates that? Now, while expanding, we have one coefficient. What is that coefficient means? Minus 1 power 1 plus 1. Minus 1 power 1 plus 2 minus 1 power 1 plus 3. These coefficients we have to continue. How we got 1 plus 1, 1 plus 2, 1 plus 3 sir? Which indicates the suffixes of the element. Here A11. Here you have one row and one column. Here one indicates first row and another one indicates the first column. Here whenever we are using Aij is the element, we have to consider as the coefficient is minus 1 power I plus j. Here the value of I is 1, the value of j is 1, so that we are taking minus 1 power 1 plus 1. Next, A12, first row, second column. So minus 1 power 1 plus 2, I plus j. 1, 3, first row, third column. So minus 1 power 1 plus 3. So these coefficients are very, very important. So this is the way we can expand a 3 by 3 determinant. So how to convert in the sense? Converting a 3 by 3 square matrix into the form of a 2 by 2 square matrix. So this kind of expansion you can do by using either row 1 or row 2 or row 3 or column 1, column 2, column 3. Using any row or any column, we are able to find the determinant of a 3 by 3 square matrix. Means that finding a determinant for a 3 by 3 square matrix, we have 6 ways. Choosing any way is your choice, but usually we expand in which row or in which column we have maximum number of zeros. If you have more number of zeros, so 0 into anything, 0 into anything, the calculation will be very easy. So that kind of strategy we have to use while calculating determinant of a 3 by 3 square matrix. Now we see one example to understand this concept. Here we have one example number 3 to understand the concept of finding the determinant of a 3 by 3 square matrix. As I told you that the determinant can be calculated in 6 ways. Using 3 rows and using 3 columns, totally we can have 6 ways of finding the determinant of a 3 by 3 square matrix. Here, to understand that concept, we have taken one example problem and I am explained 3 ways of finding the determinant. Here the first case, the given matrix is evaluate the determinant. The determinant always we denote with delta. So the triangle symbol we used to call as delta. Delta indicates that direct determination. So delta is equal to det 1 2 4 minus 1 3 0 4 1 0. We have 3 rows and 3 columns. We can find the determinant using row 1 or row 2 or row 3 or column 1, column 2, column 3. Any row or any column can choose to find the determinant. Here in case 1, I am finding the determinant by using row 1. That expanding with row 1. Now let us see how to expand. Now choosing the first row elements. Now 1, 2, 4. First expansion we are taking. 1 into. As I told you that when we are choosing the element 1, we have to eliminate the corresponding column and corresponding row elements. By leaving the corresponding row elements and column elements, now you are able to observe only 4 elements. 3, 0, 1, 0, which indicates a 2 by 2 square matrix. So 3, 0, 1, 0 we are writing as 2 by 2 determinant. Now second element minus 2 into. Again leaving this entire row and the entire column. So we are leaving the row and we are leaving the column elements. Then we are able to have minus 1, 0, 4, 0. So minus 1, 0, 4, 0. It is again a 2 by 2 determinant. Now next the third element plus 4. Now leaving the row and leaving the column elements, now you are able to observe 4 elements. Minus 1, 3, 4, 1. That we are writing minus 1, 3, 4, 1. Now you may have a doubt. So how we got minus here? We have plus 2, plus 1, plus 4. How we got minus? As I told you that every number has to multiply with the coefficient minus 1 power I plus j. When this coefficient we no need to write every time, we have to remember that when we are choosing the first element, it indicates plus, minus, plus. Alternate signs will come. So the first element is even. The second element is odd. Again even. Even, odd, even. That kind of alternate comes. So that first plus, second minus, again plus. So directly we can do this. We no need to write every time minus 1 power I plus j. So that directly I am taking it as plus value, minus value and again plus value. Now you can simplify. 1 into the det as you know 3 zeros are 0, minus 1 zeros are 0, minus 2 into, minus 1 into 0, 0, 4 into 0, 0, plus 4 into, minus 1 into 1, minus 1, minus 4 3s are 12. Now 0 minus 0, 0 into anything is 0, 0 minus 0, again 0 into anything is 0. Now minus 1, minus 12, minus 13, minus 13 into plus 4, plus into minus, minus 13 4s are 52. So finally the given 3 by 3 matrix order and the determinant is minus 52. This is about expansion with row 1. Now the same problem I am going to solve using expansion with column 1. Now let us see. When I choose column 1 means these are the elements I have. As I told you, the first element 1 gives us positive, the next element gives us negative, next element gives us positive. This is the order. Positive, negative, positive. As I told you, when we are choosing column 1, let us think about the first element. Here I have the first element 1. So 1 into. As I told you, when we are choosing the element 1, we have to leave the entire row elements and the entire column elements. So leaving the first row and leaving the first column. Again we have a 2 by 2 determinant, that is 3 0 1 0, that we are writing here. 3 0 1 0. Now taking the second element minus 1. As I told you, here we have a symbol minus and the element is minus 1. So minus of minus 1 has to come. So minus of minus 1. And again, as we know that minus 1, when we are choosing the minus 1 element, we have to eliminate the respective column and the respective row. So eliminating this entire row elements, we have 2 4 1 0. So 2 4 1 0 we are writing. Next plus, now we are choosing the element 4. When we are choosing element 4, leaving the first column and third row, now we have these elements. So leaving the third row and leaving the first column, we have the element 2 4 3 0. 2 4 3 0. That we are writing here 2 4 3 0. Now this we can expand it. So 1 into 3 zeros are 0, minus 1 zeros are 0. Minus of minus becomes plus 1 into 2 zeros are 0, minus 1 4s are 4, plus 4 into 2 zeros are 0, minus 3 4s are 12. Now again by simplifying, here 1 into minus 4, minus 4, 4 into minus 12, minus 48, finally we have minus 52. When we use row 1, our answer is minus 52. Using column 1 also we have minus 52. And I gave one small trick, how to calculate the determinant in the easiest way. Once we need to observe the given matrix and we need to find whether we have more number of zeros either in any row or any column. When we observe here, in column 3 I have more number of zeros, means I have 2 zeros. Now choosing column 3 is very easy to find the determinant, that also we have here. Case 3, expanding with column 3. So when we are choosing the column 3, again here 4 is positive, 0 is negative, again 0 is positive. Now directly 4 into means leaving the first row and leaving the third column. We have only these elements. So leaving the first row and leaving the first column, we have the element minus 1 3 4 1, that we are writing. Next we have zeros. You don't need to write anything, just only for your understanding I have written. General case, you don't need to write these parts, directly you can take with 4, because 0 into anything is 0, 0 into anything is 0. In that way the calculation is very easy for us. So 4 into minus 1 into 1 gives us minus 1, minus 4 into 3 gives us 12. So minus 1, minus 12, minus 13, minus 13 into 4, minus 52. These no need to calculate because all these values gives us 0. So in that way the calculation is very easy when we choose column 3. So using row 1 or using column 1 or using column 3, you can choose any row or any column, your answer will be same. Minus 52, minus 52, minus 52. In this way, we can find the determinant of a 3 by 3 square matrix 6 ways. As per our convenience, we can choose any row or any column. Another exercise problem to find determinant of a 3 by 3 square matrix. The matrix was given A is equal to 1, 1, minus 2, 2, 1, minus 3, 5, 4, minus 9, and find det A. In our previous example, we have taken row 1, column 1 and column 3 to find the determinant. Here I am choosing column 2 to find the determinant. So we have 6 ways of finding the determinant, choosing 3 rows or 3 columns, so that we are choosing column 2. In a question, just they ask find det A. They never mention use column 1 or use column 3 or use row 1 or row 2. Choice is yours, choosing either any row or any column. Here, by choosing column 2, how to find the determinant? Now, what are the elements we have in column 2? We have the elements 1, 1 and 4. Now, using these column 2 elements, we are expanding the matrix. Then how? Before expanding that, we have to know the coefficients of each element. Now, usually the coefficients of this 3 by 3 square matrix are like this. First we start with positive, positive, negative, positive, positive, negative, positive. Like that, the positive negatives will come alternatively. Here positive, negative, positive came. Then negative, positive, negative, positive, negative, positive. Means that leaving the respective row and respective column, we have the element 2, minus 3, 5, minus 9. So 2, minus 3, 5, minus 9. Now minus 1 into 2 into minus 9 gives us minus 18, minus 5 into minus 3 gives us minus 15. Now coming to the second element 1. When we are choosing the second element 1, its respective coefficient is plus. So that we are keeping plus 1 into. Now leaving the respective row and respective column, we have the elements 1, minus 2. So here I am removing this second column and second row. When we eliminate second column and second row elements, we have the elements 1, minus 2, 5 and minus 9. So 1, minus 2, 5, minus 9. Next, the third element. We have the third element is 4. Now the coefficient of 4 is nothing but minus. So that we are keeping minus 4. Now when we talk about 4, we have to eliminate the corresponding row and the corresponding column. Means we are eliminating the second column and third row elements. When we eliminate second row and third column, second row and third column, here we have 1, minus 2, 2 and minus 3. These are the elements we have. So 1, minus 2, 2 and minus 3. So using column 2, we are expanding. Now we are able to simplify. So minus 1 into, as I told you, 2 into minus 9, minus 18, minus 5 into minus 3, minus 15. Now plus 1 into minus 9, minus 9, minus 5 into minus 2, minus 10, minus 4 into 1 into minus 3, minus 3, minus 2 into minus 2, minus 4. Now minus 18, minus of minus becomes plus 15. 1 into minus 9, minus of minus plus 10, minus 4 into minus 3, minus of minus plus 4. Now minus 18 plus 15 gives us minus 3, minus 3 into minus 1 gives us plus 3. 10 minus 9, 1, 1 ones are 1. 4 minus 3 plus 1, 1 into minus 4, minus 4. Finally, we get the answer 0. So, here I have explained choosing column 2. You can try by taking row 1 or row 2 or row 3 or column 1 or column 3. Anything, you will get the same answer 0. This is the way we can find the determinant of a 3 by 3 square matrix.